It was a Russell's viper. Janita landed in hospital. The venom had played havoc. Doctors battled, but treatment failed. 13-year-old Janita's vital organs gave up one by one. Janita, just one of the nearly 50,000 Indians who die of snakebite each year. The big four venomous snakes of the country continue to strike fear. A hiss louder than any other, Russell's viper, feared, responsible for the highest number of snakebite deaths in India. Its venom breaks cells down, causing hemorrhage and death if untreated. Cobra, the Nag, revered, feared, found almost in the whole of India. Its venom, a powerful neurotoxin, leads to paralysis. Cobra, responsible for nearly 30% of all snakebite deaths. The common Krait, found almost in the whole of India, one of the world's most venomous land snakes. Active at night, known to enter homes looking for rats. Encounters common. Its bite painless, but its venom, fast-acting, brings on paralysis and, if untreated, death. And the fourth of the big four, the saw-scale viper. Its size is small, but speed spectacular. With its very fast strike, its venom attacks the clotting agents. The saw-scale viper, responsible for nearly 5,000 deaths each year. But this is not the story of just the big four venomous snakes of India, but also important areas of research. 4 scientific teams, different skills, different areas of work, but the same goal: saving lives. A story of death, suffering and loss, yet without villains. Ancient creatures evolved to survive. India, with her natural diversity, is home to many species of snakes. Snakes do not lurk in nooks and corners to attack humans, but encounters happen. Snake venom, a cocktail of proteins and enzymes. The legless, armless snake's weapon to catch and digest its food. When venom enters the human body, it starts its job. It eats muscles, damages nerves, destroys blood. Any bite by a venomous snake is a medical emergency. But doctors have limited choice. They do not know the species of the biting snake, nor the amount of venom that has been injected. They wait for the symptoms to appear and then start giving the available anti-venom, a concoction of antibodies for all the big four venomous snakes of India. This treatment itself fraught with risk. There are chances of an allergic reaction, of organ failure, the need for dialysis, respirators, ventilators, antibiotics, body fluids, blood and serum. It's a long, expensive hospital stay and for many, a losing battle. Ironically, the treatment itself has remained unchanged for the last more than 70 years.
There is a lot of lacunae in treating that because we don't have a consensus and there is no national protocol. Every doctor uses his own methods, which may or may not be correct. So it's a big challenge. There are so many areas which still we don't know how the snake venom acts.
The snakebite problem is multifold, complex. We do not know enough, do enough. Why should 50,000 Indians die each year, even in this day and time? In the University of Mysore is Dr. K. Kemparaju. His Department of Biochemistry specializes in venom composition. The team studies the toxicity of venom to understand its effect on tissues and cells. This box has the venom of all the big four, enough to kill all in this room. Naja Naja, the Cobra. Cobra venom from Mumbai in the west, Chennai in the south, and Kolkata in the east. Each bottle has Cobra venom, but is the venom the same in each bottle? Precision is the backbone of scientific research. Dr. Kemparaju is working with the Cobra venom from the south of India. He weighs out the required quantity. This venom is as expensive as gold. The purpose is to study the specific composition of proteins and enzymes in this sample. The techniques are many. The team has been comparing the composition of snake venom across different regions of India. Like many in the field, he has long suspected that the venom of the same species of the snake would vary with difference in geographical conditions.
We know there is a lot of geographic variations in venom composition, and the Cobra venom that is there from the Delhi region or Kolkata region or Mumbai region, Chennai region, Karnataka region, they tremendously vary with respect to their the toxin content.
A volunteer offers to be bled. The team would be testing Cobra venom. Cobra venom is known to be a neurotoxin. It brings on paralysis by attacking the nervous system. But what is its effect on blood? Each test tube contains the same quantity of blood with an anti-clotting agent added to it. To each test tube would be added the same measured quantity of Cobra venom from different regions: east, west and south. One is the control with no added venom.
Eastern regional venom decrease the clotting time of blood. It acts as a procoagulant in it. Act as procoagulant. This is western and this is southern, and in this case there is no clotting.
The difference in venom action is clear. Cobra venom from the east of India acts on blood too, in addition to attacking the nervous system. India is amazingly diverse. The sandy, dry deserts of Rajasthan are home to the cobra. But here, it must have evolved to the harsh conditions of the desert, to the prey base available here. Very different from the southern cousin, where the water inundated paddy fields provide a different prey base. Different survival tools, different venom composition. To understand the significance of these findings, one needs to understand how the anti-venom is produced in India. And that story begins with the Irula snake catchers. Irulas are traditional snake catchers. Their knowledge and skill of tracking and catching snakes unparalleled by any in the world. At this unique cooperative on the outskirts of Chennai in Tamil Nadu, they are licensed to handle each of the big four. They catch snakes, milk them, and supply the venom across the country. All the anti-venom made in India comes from the Irulas, from snakes in the south of India. Kaliappan and Mariappan, two experienced members of the Irula society, out in the field to capture a cobra. They look for telltale signs. All we can see is a huge expanse of open land, but the land reveals far more to these snake experts. They are confident. This is what they have seen since childhood. This is their traditional livelihood. The cobra, large and angry. A bite could kill, but Kaliappan is deft. He will get his money for the catch. The cobra would be milked for venom once every week for the next 1 month, and then marked and released. At the Irula Society, each of these pots holds a venomous snake. A Russell's viper is milked and the cobra would be next. These drops of deadly venom will go to some lab or pharmaceutical company. The Irula Society is the only venom supplier for the whole of India. The liquid venom, dried into a powder, is sold under strict licensing. All anti-venom in India is made from this venom collected by the Irulas in the south of India. And this is how it's made. Horse is the animal of choice. It's injected with a small purified dose of venom. The dose cannot kill or harm, but kickstarts the horse's immune system. Antibodies are produced. The process is repeated with increasing dosage of venom. Over time, the horse blood has enough anti-venom for extraction. It's a complex process. The final anti-venom, the poly-anti-venom, has antibodies against the venom of all big four, but made from the venom of southern snakes. Would this work against snake bites in the north, east or west? Dr. Kemparaju's lab seeks the answer. It's a standard scientific test. A nutrient-rich plate is prepared. Once it dries, depressions are made on it and marked carefully. At the center is AV, the anti-venom, and around it would be drops of cobra venom from the east, west, and the south of India. Not clear to the layperson, the test proves that the available poly-antivenom is not as effective against the eastern cobra. This very concern is being voiced by experts across the country. In Angamally, Kerala, the Little Flower Hospital has been spearheading snake bite treatment research.
Basically, we are making anti-snake venom mostly against snakes from the southern part of our country, which does not cover for the north, which does not cover for the east, and least of all for the northeast.
But the problem is not just venom variants. In the hospital was another cobra bite victim. Kamla, Unable to breathe, her brain function hampered. She was given 20 poly anti-venom injections in 2 hours. Doctors knew that it was a cobra bite, but had no option but to give her anti-venom for all big 4. The anti-venom reaches the body, seeks the venom, surrounds it, makes it ineffective. Venom is neutralized. It can cause no further harm. Kamla stabilized, but was saved with a huge hospital bill following complications due to excess anti-venom. She was also lucky to be in the south of India.
We have to give unnecessary anti-venom proteins. When a patient is bitten by a cobra, why we should give proteins for, protein of viper, or protein of hypnale, or protein of Krait.
In a systematic study of more than 1,200 snakebite patients, experts at the hospital have documented allergic reactions in close to 30 to 35% of those who were treated with the standard available poly anti-venom.
Nobody lost their life related to this allergic reaction, but there was this allergy to horse globulin. Why this allergy? Because what you're giving by way of ASV is actually a protein which is foreign to humans. You're giving a horse globulin, you're giving a horse protein. So which is why the body reacts against the horse proteins.
Why has the production technique remained the same over the last 70 years? Our search for answers took us to Coimbatore. The microbiology department is working with the chicken. It's a unique quest, one that aims to produce snake anti-venom using chicken eggs. Dr. A. Michael prepares an injection, a highly purified and a very small dose of venom, a specific protein. This chicken has been receiving similar injections, has remained healthy and under tight supervision. With venom in its blood, the chicken joins the others. While this one got the naja or cobra venom, others have been injected with venom from the Krait, Russell's viper and the saw-scale viper, each of the big 4. The chicken immune system gets busy. The animals remain healthy, but their body produces anti-venom. Venom and anti-venom are like lock and key. The anti-venom can seek the venom. The chicken passes the anti-venom to its egg. Each chicken lays about 250 to 300 eggs in her lifetime, and each of these eggs contains specific anti-venom proteins.
And the antibodies which we have raised, it's purer than an equine anti-venom. So it will 10 to 15 times it will be better than what is existing today.
10 to 15 times better than equine or horse anti-venom. It's a tall claim, but extracting these proteins from the egg yolk is what the team specializes in. It's a multi-step procedure. The egg yolk contains the anti-venom, and to extract the anti-venom, the process of filtration and purification is repeated over and over. The protocol has been developed and tested.
Chicken has got lesser reactions because it will not trigger any anaphylactic reactions. And we can purify the antibodies very easily from the eggs. We are not going to touch the chicken. Only collecting the eggs and storing at 4 degrees centigrade, purifying the antibodies, it is animal friendly.
The The purified anti-venom extracted from the chicken egg is being dried. The yield compares well with the production from the horse. No study is complete without testing. The PSG team has tested the efficacy of its anti-venom. They have been testing their anti-venom in rabbits as well as mice successfully. Dr. Michael is confident that this technology is far superior. In the long run, it will be safer, precise and cheaper. It will lead to snake-specific mono-antivenom. Our next halt, the University of Kerala, Thiruvananthapuram. It's a small team of specialists at the Department of Computational Biology and Bioinformatics. In this lab, there is something that could revolutionize snakebite treatment in our country.
And today we can very confidently say that we would come out with a biosensor to detect the snake bite in the next 6 months' time.
A biosensor to detect snakebite? The test version is ready. The sensor can handle all the big 4 snake bites. The strip is the antibody-coated sensor. The sample here is snake venom, but which one? Not just the specific venom, the kit even reveals the quantity of venom circulating in the system. Making this biosensor has been a challenge. The team has isolated snake-specific antibodies for each of the big 4. These are the backbone of the test, a bedside test that would take just 20 minutes. This kit has a large electronic component, a brilliant example of multidisciplinary science.
Nowadays, the clinician depends upon, adopts the symptomatic approaches. He waits for the symptoms to come, for example, nausea, vomiting, anti-clotting, and all. He wait for that. Now we can do away with that, and in about 20 minutes time, we should be able to immediately start the treatment. You can save the precious time.
To understand the significance, let's imagine the scenario. A snakebite victim comes in. The doctors have no means to find out which snake has bitten and whether there is venom in the body or not. They watch and wait.
So if a patient comes with a snake bite, we keep him or her in triage in the casualty, and we wait for the symptoms to develop, which is actually what is catastrophic. You are treating a disease after the venom has actually come and had its effects.
It's catch-22. Waiting for symptoms is catastrophic, as damage caused by venom is irreversible and almost immediate. But then anti-venom cannot be given without being sure of presence of venom in the system. Let's rewind and imagine an ideal scenario. Janita, bitten by a snake, is rushed to the hospital. The doctors waste no time. They take a sample of blood from the bite site or even urine, place it on the sensor, and the sensor reveals the facts. Without losing any time, the required dose is given. Dose of mono antivenom specific to the Russell's viper. With minimal danger of allergic reaction or organ failure, Janita could be saved.
So we have to have our own research and save our own people.
Our belief is there should be at least 5 zones in which you have these regional pools of venom from which an anti-snake venom could be manufactured. This would make the treatment very much more effective than what we have right now.
First thing is that we should know what snake is bitten. And if we can give them a monovalent antivenom, that would be the best.
Once a biosensor is successfully developed, there will be several takers to come forward to manufacture monovalent antivenom.
Government of India should see that the outcome should reach the beneficiaries, and they should provide the facilities, medical facilities for these people at a very cheaper level or with no cost also.
Snakes bite 1 million Indians every year. Of these, 50,000 die, but they need not.